All right, y'all. So 4.8 deals with applications. So the first thing they do, let me go to Math Lab and bring up 4.8. So the first two problems they're going to give you a graph of a parabola, and they want you to give the x-intercepts and then give the solutions. So remember, while ago we said the solutions were equal to the x values of the x-intercepts. So watch how you do this. First, they want the x-intercepts. Well, x-intercepts have to be like an ordered pair. So they're going to be in parentheses. So I'm going to do the one right here on the left side. That x-intercept is at -1 and has a y value of 0. So that would be -1, comma 0 for the first one. And then shut my parentheses, then comma, and then open my parentheses for my second one. So the second one over here on the right side, that's crossing the x-axis at 5. So that one would be 5, comma 0, and then, whoops, and then shut that parenthesis. So let me shut my parentheses. So once you shut your parentheses and enter, so after you put in the two x-intercepts, you're going to hit OK. And then it wants the solutions. Well, remember, the solutions were equal to the x values of the intercepts. So that would be the -1, comma, and then 5 for the second one. So they just want you to realize that you can find the solutions if you can graph them and know those x-intercepts. So y'all the same thing on this one. Parentheses for your x-intercepts. So let me make that a little bit larger. So over here on the left side, well, that's -1 again. So that one would be -1, 0. And then close parentheses, and then comma. Whoops, let me go back and make that a comma. And then open up my parentheses again. And then the second one over here to the right, that's crossing that 3. So that one would be 3, 0. And then close your parentheses. So just remember, x-intercepts have to be like an ordered pair. And then the solutions would be what? The -1, comma, 3. All right, so those are fun, but what we're wanting in this section is these next questions. So y'all, let's see what we got here. A wire is stretched from the ground to the top of an antenna tower. So I'm just going to sort of draw that and then I'll come back to my picture. So you got a wire stretched from the ground to the top of this antenna tower. The wire is 13 feet long. Then it says the height of my tower here. So the height of the tower is 7 feet greater than the distance D. And they're saying distance D from the tower's base to the end of the wire. Then they want to know is they want me to find the distance D and the height of my tower. Okay, so let's go play with this one as a picture. So here's this antenna tower over here, and here's this wire. Okay, now the wire is 13 feet long. I know that. Then it tells me the height of this tower here So the height of this tower is 7 feet greater than the distance D, and distance D is from the base of the tower to the end of the wire. So they're saying that this distance right here is distance D. And the height of my tower over here is 7 feet greater than that distance. So that's going to be D plus 7. All right. So what they want you to realize is you have a 90-degree angle here. That makes this a right triangle. Okay. And we got a formula that I can use that relates to sides of a right triangle. And that's going to be the Pythagorean theorem. So to solve this, we're going to use a squared plus b squared equals c squared. Now it's a little bit picky. C squared, the c side has to be the longest side. No matter what, C will be what we call the hypotenuse every time. Now A and B, it don't matter which one's A, which one's B, okay? So I'll let this one be A for me, and then this side, I'll fill in for B. Okay. But like I said, A and B, it don't matter. The only one that does matter is C has to be your hypotenuse, okay? All right. So let me replace what I got for A, B, and C. A would be D, so that'll be D squared. B will be D plus 7 squared. So remember, this whole side getting squared. And then C squared will be 13 squared. So you plug in for your three sides. Okay. So next, I'm going to work this. I cannot do nothing to the D squared. But let me work on the side here and figure out what D plus 7 squared equals. Because once I figure that out, I'll put it down here. So D plus 7 squared is D plus 7 times D plus 7. So the big mistake on this is people square the D, they square the 7, and they put a D squared plus 49 here. That's not enough. When you got a D plus 7 squared, you got to write this twice and FOIL. So D times D is D squared. D times 7 is 7D. 7 times D is 7D. And then 7 times 7 is 49. So this will give me a D squared. 7D plus 7D is 14D plus my 49. So this will replace this. D squared plus 14D plus 49. All right, 13 times 13 would be 169. All right, y'all, so let's see what I'm going to do. D squared plus D squared gives me 2D squared plus my 14D plus my 49 equals 169. So it's quadratic because of these D squareds in here. So since this is quadratic right here, I need to make this into a 0. So to make this a 0, I'm going to subtract 169 from both sides. All right, y'all, so let's see what that does. That's going to give me my 2D squared plus 14D minus 49 minus 169 gives you a negative 120. All that equal to 0. Okay, so Looks like I sort of got something looks like a quadratic formula now. Okay, so let's figure A equals, B equals, and C equals. A will be 2, B will be 14, and then C is a negative 120. We're now going to plug that into our quadratic formula and get two answers. But y'all, since this is a distance problem, I can only keep the positive answers. Any negative answers, I got to throw away, okay? Because we're dealing with distance, and distance cannot be negative. So let's get our two answers. X equals negative B, which is 14, plus or minus square root. B squared will be 14 squared minus 4 times A, which is 2. C is a negative 120 all over 2 times my A, which is 2. All right, so I'm all plugged in. So that's going to make this a negative 14 plus or minus square root. 14 times 14 is 196. And y'all, let's multiply this. Negative 4 times 2 is negative 8. And then you got negative 8 times a negative 120 gives us 960 all over 2 times 2, which is 4. All right, y'all, let's add this under the radical. So I bring down to negative 14 plus or minus 196 plus 960 gives us, so what I got gives me 1156 all over 4. Let me make sure I'm right on that. 196 plus 960 is 1156. All righty. Bring down that negative 14 plus or minus. Now on the word problems, these will be perfect squares. So let's go figure out the square root of 1,156. So I'm going to go to my calculator. I want to get off the graphing. So square root will be second x squared, and then I'm putting in my 1156. So let me see what my chat got. Okay, so since we're just wanting the square root of that, the square root would be the 34, okay? All righty, so the square root of 1156 was 34. So y'all, let's go back and, so on the word problems, they will be perfect squares. So that means you're looking for what number times itself gave you that 1156. So Jason, that'd be your 34 there. So this would be negative 14 plus or minus 34 over 4. So let's get the first answer by adding. So negative 14 plus 34 divided by 4. So negative 14 and 34 give me 20 over 4, which gives me 5. Now y'all watch this second answer would be negative 14 minus 34 over 4. So this one would give me a negative 48 over 4, which is a negative 12. Remember, distance has to be positive, so you got to throw away your negative answer. So that means this side B has to be 5. So if this side D is 5, how tall is the tower? Well, the tower was D plus 7, so that'll be 5 plus 7 which gives me 12. So the distance is 5, and then the height of my tower would be 12. So you would go back to MATLAB and let's see how they want it. So the distance from the wire to the tower, that would be our 5. And you would check that answer. And then the height of my tower was the 5 plus 7, which gave us, whoops, that should be 12. And then check your answer. Okay, so that's the trick on that one. So y'all look at this one. The foot of a ladder is 3 feet from a wall. Then it says the height the ladder reaches on the wall and the length of the ladder are consecutive integers. So the height ladder reaches on the wall and the length of the ladder are consecutive integers. Then they want to know, only thing they want to know is how long is that ladder? Okay, so let me go back a second on something. Someone was asking me, where's 5 plus 7? Okay, so I got that. Let me go back up here. So I got the 5 plus 7 to get my 12 because of this D plus 7 up here. Okay, you got it? Okay. All right, y'all. So this will be another one. So let's see what we got. We got a wall right here. And up against my wall, I got a ladder. Now, the first thing I know, the foot of this ladder is 3 feet from this wall here. So this distance right here is 3 feet. Then it tells me the height my ladder reaches on the wall here and the length of my ladder are consecutive integers. What that means is consecutive integers are numbers that are in order, like 1 and 2, 5 and 6, 10 and 11, 13 and 14. So what that means is when you say two things are consecutive integers, if I let the height the ladder reaches on my wall be x, then that means the length of the ladder, if these are consecutive integers, to go from one integer to the next one, I add 1. So if this is x, that means the length of the ladder is x plus 1, okay? And y'all, that's what they mean when they say consecutive integers. X plus 1. 5, 5 plus 1 will make that 6, okay? Now what they want you to realize, you got another right triangle. So that means to solve this, I'm going to use our formula. A squared plus B squared equals C squared. So our Pythagorean theorem again, okay? Now remember, I don't care which of these two sides is A and B, but what I do care is that this longest side is my hypotenuse, and that makes it my C. And I'll just call this one A and that one B. But it don't matter which one's which, okay? All right, so let me fill in. So mine, I said A would be 3, so that's going to be 3 squared plus B, which is x squared. That's going to equal my C, which is x plus 1 squared. Now, when y'all work this, the only difference on y'all's problem and mine is your A might not be 3 like me. You might have a 5, 6, 7 here, but you're going to have an x squared here, and you're going to have an x plus 1 squared here. Everything is going to be identical as we work this problem, other than that 3, okay? Right, y'all, so let's break stuff out. 3 times 3 is 9, plus, can't do nothing with that x squared, but I'm going to have to, on the side, figure out what x plus 1 squared is. And we're all going to have an x plus 1 squared here. So Jesslyn, FOIL. So we're going to FOIL that again. All right, y'all. So you're going to FOIL this and then replace that right here. So x times x was your x squared. X times 1 is 1x. 1 times x is 1x. And then 1 times 1 is a 1. So I'm going to add the like terms. So bring down the x squared. 1x plus 1x gives you 2x. And then bring down your 1. So y'all, this side becomes x squared plus 2x plus 1. Every one of y'all on the right side will get this, okay? And you'll all get an x squared on this side. The only difference is that 9. So you see the x squareds? Your first move is to try to get all the x squareds on one side. So to move this x squared to the other side, you would subtract it. But you're going to see something happen here. This 9 will come down. Well, y'all, what happens to these x squareds here? I got an x squared and a negative x squared. They're sort of going to cancel out. So those x squareds cancel. So then I got my equals. Well, y'all look at these x squareds. You got a positive x squared and a negative x squared. They're going to cancel. So if you got an x squared on one side and an x squared on the other side, they're basically going to cancel out. So I get my 9 equals, all that's left is the 2x plus 1. So it's not even quadratic anymore. And everybody, when y'all do this, you're going to have your number equal to 2x plus 1. You'll have the same thing as me, other than that 9, okay? So look here. It's not quadratic no more. We don't have no x squared terms left down here. So we're not doing the quadratic formula. All we're going to do on this one is solve for the x. So it's not quadratic on your latter one. So to solve this for the x, I'm going to move this one over by subtracting. So 9 minus 1 gives me 8 equal to my 2x. And y'all, you're going to solve y'all's the same way. You're going to subtract 1, and then you're going to have 2x, which means you're going to divide everybody by 2. So 8 divided by 2 gives me 4 equal to my x. So y'all, this side is going to be 4. But what they want to know is, how long is my ladder? All right, y'all, so how long is my ladder? All right, let's see. Well, we said x was 4 right here. So if x is 4, my ladder was x plus 1, which would be 4 plus 1. And what y'all got, Julie? I'm going to go with my ladder is 5. Yeah, don't square that. Remember, if this x was 4, then 4 plus 1 gave me 5 for my ladder, okay? Oh, y'all, so that's what MathLab wants is that 5. So you would go back, um, go to your ladder, put in 5, and then check that answer. All righty, y'all. So that was 4.8. And it was just mainly dealing with the Pythagorean theorem, okay? Now remember, one of those problems, number 3, I had to do a little quadratic formula to. And then the number 4 problem on that section, when you solve it, the quadratic stuff goes away. So you're just solving it for the x. But remember, when you get to x, that ladder is x plus 1. So add the 1 to that before you put in that answer for that ladder, okay? All righty, so since we got time, I'm going to show you how to do support 7.4, and then you got support for 4.8. So 7.4, their support was mainly solving the quadratic stuff by factoring and square roots. It was the first 2 ways I said you could solve quadratics. Remember, I said you could factor, and then I said you could take square roots. And the third way was the quadratic formula. So these are going to deal with the first 2 ways, okay? So we're going to solve each. So number 1, I got x squared plus 64 equals 0. So this one doesn't have the x term in the middle. It's got an x squared and a number. So this one, I'm going to solve by square roots. So when you solve them by taking the square roots, you try to get the x squared by itself. So to get the x squared by itself, I would subtract 64 from both sides. That's going to bring down my x squared. That's going to cancel. And 0 minus 64 is a negative 64. Once you get the x squared term by itself, you're going to take a square root of both sides. So square root of x squared will equal the square root of negative 64. So y'all, the square root of x squared gives you an x. So this radical sort of cancels out that exponent. Now, these square roots, remember, are going to be plus or minus. Anytime you take a square root of a number, you're going to put a plus or minus in for it. So let me ask y'all this. What is the square root of a negative 64? What would y'all put for that square root? Now, so it will be an 8, but what kind of 8? Now, it can't be like a negative 8, remember, because negative 8 times negative 8 would make that a positive 64. Ooh, and a positive 8 times positive 8 makes that a positive 64. So what did I say happened when you had that negative under that radical? Do you remember? That'd be like a 64 times a negative 1. So Mackenzie, Jason, y'all are on the right track now. So the square root of a negative 64 would actually be what? An 8i. So your answer would be x equals plus or minus 8i. Okay? So remember, square roots of negative numbers will give me imaginary numbers. All right, then the second one, they had an r squared minus 4r minus 32 equals 0. So this one factors, R squared would be an R and an R. Now, y'all watch this one. That last number is negative. Anytime your last number is negative, you're going to have one positive factor and one negative. Because a positive times a negative makes a negative. Now, since the last number is negative, I would find factors of 32 that subtract to get 4. So find factors of 32 that subtract to get 4. So what can y'all multiply to get 32? And those two numbers will subtract and give me a 4. So y'all, we would actually use our calculator if you want to, remember. We can go to that y equals. So y equals, I'm looking at 32. So make this a 32 divided by x. I'm going to go to the table, second graph. So I need two numbers that will subtract and give me a 4. So 1 and 32 don't work. Oh, y'all, look at that. 4 and 8. 4 and 8 would subtract and give you a 4, okay? So this would be 4 and 8. So check this out. The larger factor will have the same sign as the middle number. So that's going to make that 8 negative and the 4 positive. So watch this. Negative 8 and 4 equal negative 4. 4 times negative 8 equals negative 32. So remember, if the last one's negative, you want your factors to subtract to get the middle number. And while go, the one where I did it was positive, you wanted the factors to add and get the middle number. All right, now to finish this, you set both of them equal to 0, remember? So the first one, I subtract 4. R is a negative 4. So the answer has an opposite sign in the factor. And here, since R was minus 8, to solve it, I would add 8, and I get a positive 8. So when you're solving them, all you're doing is changing the signs up here, okay? All righty, y'all, watch this one. 5x squared equals 55. So this one I would do just like I did here. I would solve it by doing square roots. So the only thing I got to do to get the x squared by itself with a 1 in front of it, I'm going to have to divide both sides by 5. So let's divide both sides by 5. So that cancels, giving me my x squared. And then 55 divided by 5 is 11. All right, so the x squared is by itself. So now I'm going to take square roots of both sides. So the square root of x squared is x. That's going to equal a plus or minus. So y'all, let me ask you this. Can I do anything to simplify a square root of 11? All right, Jesselyn, good job. That is definitely a no. So my final answer will be x equals plus or minus square root of 11. So remember, when you write your final answers, you got to have two answers since this was an x squared. The exponent tells you how many answers you get. So I get a square root of 11 and a negative square root of 11. So you can write the answer using the plus or minus, or you could do x equals square root of 11, comma, negative square root of 11. Either way, me personally, I usually use that plus or minus when I do it. But y'all, like I said, either way, okay? All right, y'all, we got a couple more in this section. So number 4, they had 2x squared plus 14 equals 0. So notice, I don't have the x term again, so I'm going to square root it. So a lot of this support was doing square root stuff, okay? So we got to subtract 14 first, because we got to get that x squared by itself. So the 2x squared, that cancels. So that's going to equal negative 14. Then I want to divide by 2. So that cancels. X squared is now equal to a negative 7. All righty. X squared by itself, so I can square root now. Square root of x squared is x. This is going to be plus or minus. So no matter what, in front of your final answer, I need you to have a plus or minus here. So I know I can't do nothing with the 7. But remember, we got to bring out that negative. So that square root of negative 7 needs to be a square root of negative 1 times a 7. And then the square root of negative 1, you're going to get an I and then square root of 7. So this final answer will be plus or minus. Bring out the negative as the I and then square root of 7. Okay? Now, if you desire, it can be plus or minus square root of 7 and then the I. But y'all listen, you cannot put that I under that square root. If you do, it will mark it wrong. The I has to be outside, okay? That's why a lot of times I put my I first, so then I can't get it accidentally under there, okay? All right, y'all, watch this one. X squared plus 16 equals 0. Once again, I don't have the x term, so I'm going to square root it. So it looks like on this one, I would subtract 16 from both sides. So x squared, that's going to cancel. That's going to give me a negative 16. So now x squared is by itself. So you're going to square root both sides. So that's going to come out as an x. We know that'll be a plus or minus. All right, y'all, that's on y'all. Square root of negative 16. Oh, it's definitely got an I in it, Jesslyn, but how about that 16 part of it? Oh, well, watch this, y'all. Let me show y'all a trick. We know we got this calculator, so let me go to my main page here. So y'all watch this. Second square root, if you put a negative 16 in, it gives you an error. But watch this. I'm going to show y'all a trick. If you'll hit mode, and on mode, down here where it says real, if you'll arrow right on A plus BI and hit enter, now watch what happens when I clear the screen. Second, x squared for square root, put in that negative 16, and watch this. Square root of a negative 16 is 4i. And it'll do all those perfect squares. Negative 49 I had a while ago. If you put that in, 7i. Square root of a negative 144 is a 12i. So see, if it's a perfect square, it's all coming out perfectly, okay? So that gave me what, a 4i for that square root of negative 16 up there? Okay, so now here's the thing. Um, Yeah, positive 16 is a perfect square because that was 4 times 4. Okay. Um, so what I did, I hit the mode button and I went down here to, by default, y'all's probably has this real highlighted. So what that does is it only gives answers in real answers. And if it ain't a real answer, it'll give an error. But if you'll put it over here to the right on the A plus BI and hit enter, if you have imaginary answers, it'll give them to you now. And you can actually leave it on that if you want to. It's not going to hurt nothing else. You can still do 2 plus 3 and get 5. You can do 5 squared and still get 25. But what it does now is it lets you take square roots of negative numbers. Second square root. How about -1? Watch that. Remember what I said? Square root of -1 equaled a while ago, right? But watch this. When you hit enter, it equals I. Okay? So always change the mode if you want to do this stuff. And it will not affect anything else I'm doing if I put it into that A plus BI, okay? All right, y'all, so back on that. So that gave me what, a plus or minus 4i. So y'all, that was 7.4. So let me do, let's see, 4.8 had a few problems also. So this will be support for your 4.8. It had 4 problems. So the first one wanted me to multiply, and I'm going to multiply b minus 4g squared. So this one was to get you ready for the foiling that I did in 4.8. So this 4 minus bg squared wants me to do what? Foil it. 4 minus bg times b minus 4g. Just letting you know that when you got something being squared, you got to write it twice. So you would do b times b, get a b squared. B times -4g is a -4bg. I'm just keeping mine in alphabetical order. Here, -4g times b is a -4bg. And then finally, -4g times -4g. Negative times negative is a positive 16. G times g is a g squared. So y'all, my last step would be to add the like terms in the middle. So bring down the b squared. -4 and -4 is a -8bg. And then at the end will be a positive 16g squared. Okay, so it was just getting you ready for doing the foiling I did today. All right, the second one was the same thing, multiply. They got an x to the third plus 8 squared. So once again, write it twice. So this one, though, you got an x to the third times the x to the third. So 3 plus 3 will make that an x to the sixth. Then I got an x to the third times 8, which is a 8x to the third. This 8 times x to the third is a 8x to the third. And then finally, the 8 times the 8 was a 64. And notice, once again, you got to add the like terms. So bring down the x to the 6. 8 plus 8 gave me 16x to the thirds. Notice, I am not changing these variables when I'm adding in doing all that fun stuff. BGs stay BGs. Adding x thirds to other x thirds stays x thirds. And then at the end, I would bring down my 64. All right, this one says solve. So they're giving me a r squared plus 2r equals 0. So y'all, on one like this, they're trying to mess with you a little bit, but this is two terms, but it's got the r term in the middle. So you can't do square roots to this because that's not a number. That's got an r in it. So when you got an r squared and then an r equal to a 0 like this, the way we do this is factoring. But what we do when we factor this one, we're going to factor out a GCF. Because since this one has the R in it, this one has the R in it, we're going to factor out the R. And then in parentheses, R squared divided by R leaves you an R plus the 2R divided by R leaves you a 2. So this one, instead of undoing fulling, when you factor two terms with the variable in both of them, this one is sort of undoing the distributive property. Watch this. R times R is R squared. R times 2 is 2R. So you're sort of factoring out a GCF undoes that distributive property. But now you would set both these equal to 0. So the GCF always equals 0 when you're solving this equation, okay? No matter what you factor out, if it's the variable, it's going to equal 0. And then this one, r plus 2 equals 0. I would subtract 2, and I get r equals a negative 2. So 0 and negative 2 would be my two answers. And y'all remember, like I said, the highest exponent being a 2, that's how many answers you got to get, okay? All right, so then let's see what my fourth one is. R squared equals 9. Well, on this one, the r squared's by itself equal to a number. So I'm not going to factor it like this because this one has a number. So this one, I'm going to take square roots. I'm going to take the square root of r squared. That's going to equal the square root of 9. All right, square root of r squared is r. And the square root of 9 is going to be a plus or minus. All right, y'all, square root of 9 is what? 3. So that gives me, my two answers would be a plus 3 or a minus 3, okay? So y'all, that's sort of what the support for these lessons was getting you ready for. Was the different ways to factor, multiply, FOIL, and all that fun stuff, okay? And then the 7-4 support was more factoring and doing the square root stuff. So all of these were just playing with quadratic equations, okay? Alrighty, y'all. So questions on today. All right, so y'all are good. So here's what it is. So play with 7, 4, and 4, 8. Tomorrow we'll get into, I think it's what, 6, 1 and 6, 8 or whatever. So let me quit my recording.